Hello everyone, welcome back to the Atharva Gate Academy. Myself Chinmay Dhadu. In previous video, we have discussed the type of load, type of beam and type of support. Now in this video, we will start with the sign convention in shear force and bending moment, and then we will see some equation, and after that we will see example based on the shear force and bending moment diagram. So let us start. First of all, let us discuss sign convention of shear force. What is shear force? It is the algebraic sum of all transverse force at the left hand side or right hand side of section. Now if you remember what is transverse force is the force applied in the transverse direction, means direction perpendicular to the longitudinal direction of body. So here you can see we have this beam and we draw a vertical line here. So at this section we want to find out value of shear force. For that we will take algebraic sum of all the transverse force, either the left side of this section or right side of this section. Here we apply this transverse force in upper direction at the left side of this section. So if the transverse force is in upward direction at the left hand side of this section, then we will take it positive. And if this transverse force is in downward direction at the left hand side of this section, then we will take it negative. That you have to remember. Okay? Now let us take a small example here. Let's say value of this force is 10 Newton and we apply another transverse force in this direction having value, let's say 20 Newton. In this case, we want to find out value of shear force at this section. So what we will do? We will take algebraic sum of all transverse force at the left hand side or right hand side of the section. So here we will take the sum of left hand side of this section. So what will be the value of shear force? It is equal to this 10 Newton is in upward direction, so we will take it positive. So it will be plus 10, and here this 20 Newton is in downward direction at the left hand side of this section, so we will take it negative, so it will be minus 20. So finally shear force at this section will be minus 10. I hope it is clear to you, right? Now let us discuss sign convention in bending moment. So what is bending moment? It is the algebraic sum of moments of all transverse force at the left hand side or right hand side of section. Here we have this beam and this is the section of this beam. Now due to any bending moment, if beam is going to be bent like this, then we will take that bending moment positive. And if beam is going to be bent like this due to any bending moment, then we will take that bending moment negative. You can remember this, that if beam is going to be bent like this, means the curvature of beam is upper side, then it is called sagging of beam. And if beam is going to be bent like this, or the curvature of the beam is in the downward direction, then we can say that it is hogging in beam. Okay? Now let us take one small example for bending moment. So let's say here we have this beam and we apply 10 Newton in upward direction at this point, and let's say this distance is 100 mm. And let's say we apply this 20 Newton load in the downward direction at this point, and this distance is, let's say, 50 mm. In this case we want to find out value of bending moment at this cross section. How it can be find out? We will take sum of all the moments produced by the transverse force acting in the beam at the left side of this section. So here value of bending moment will be equal to bending moment due to this load plus bending moment due to this load. So what will be the bending moment due to this load? It will be load into distance. Here value of load is 10 and distance is 100 mm. So it will be 10 into 100. And what will be the sign of this bending moment? Understand carefully that this load is in upward direction and we take it positive when it is in upward direction at the left hand side of the section. So we will take it positive. You can also understand it like this, that if we apply this 10 Newton load in upward direction, then beam is going to be bent like this. Means there will be sagging in beam, and we will take that bending moment as a positive. So here there will be positive sign. Now here this 20 Newton load is in downward direction. So what will be the bending moment due to this load? It will be 20 into distance, that is 50 mm. And here this load is in downward direction at the left hand side of this section. So we will take it negative. So it will be minus 20 into 50. And you can also understand it like this, that if we are going to apply 20 Newton in the downward direction at the left hand side of this section, then this beam is going to be bent like this. So there will be hogging in the beam, and we will take that bending moment as a negative. So finally, what will be the bending moment? It will be 1000 minus 1000. So finally, value of bending moment will be 0. So we can say that value of bending moment at this section is 0. Fine. Now we will see formula for shear force and bending moment. So this is the formula for shear force. Shear force F is equal to integration of Wx. What is Wx? That we have discussed in the previous video. It is the value of distributed load, right? So we only need to use this equation in the case of distributed load. Either it may be uniform distributed load or it may be uniform varying load. If only point load is given, then we can directly find out shear force. Okay? Now this is the equation of bending moment. Bending moment M is equal to integration of shear force. From here we can also write that F, that is shear force, is equal to differentiation of bending moment. So it will be dm divided by dx, right? And from here we can write that Wx is equal to df divided by dx. You have to remember all this formula, okay? Because these are the very important formula that we are going to use in the example of shear force and bending moment diagram. Now we are going to solve some examples of shear force and bending moment diagram. So here is the first example. It is very simple. There is one cantilever beam, right? Means beam is fixed at one end. Normally in the exam, beam will be fixed at the left end. It will be like this. But to solve the example, we will take it like this. Means we will take the mirror image of this cantilever beam. And why we are taking like this? Because from this point, we will take this direction as a x direction and this direction as a y direction. Here in our case, we apply bending moment M at this end in the anti-clockwise direction, and here this is the beam AB. In this case, we want to find out shear force diagram and bending moment diagram. So here it is the shear force diagram and it is the bending moment diagram. Now how to find out these diagrams? First of all, we will take one section at the x distance from the origin. And at this section, we want to find out shear force. Now let's say here, length of this beam is L. So what will be the range of x? It will be 0 less than or equal to L less than or equal to L. Now to find out shear force at this section, we have to take sum of all the transverse force either left side of this section or right side of this section. Here we will see in the left side of this section. As you can see, in the left side there is only bending moment M, but there is no any transverse load. So the value of shear force F will be equal to 0 because here there is no any transverse load. So in the range of 0 to L, there will not be any shear force. So what will be the diagram of shear force? Here this is the x direction and in this direction there is a shear force. The diagram of shear force will be a line from this point to this point. Now here, what is the value of bending moment? At this section, if you want to find out, then we will take sum of all the bending moments either side of this section. So here we are going to take left side of the bending moment. Here in the left side there is only one bending moment which is in anti-clockwise direction. So if this moment is going to be act in the anti-clockwise direction, this beam is going to be bent like this. So there will be hogging in the beam and we will take this bending moment as a negative. So value of bending moment will be negative m. Here you may be confused that m is equal to minus m. Here let's say this m is mx. So bending moment in the range of 0 to L will be minus m. And it will be constant throughout this length. So what will be the bending moment diagram for this case? Here you can see this is the x direction and in this direction we take the bending moment. Now here our bending moment is negative. So our diagram will be in this direction. Here you can see this line is constant and it is having value minus m. So this distance is m and it is negative, so we will take it minus m. Now let us take next example. In this example there is one cantilever beam AB having length let's say L and we apply point load P at the end A. In this case we want to find out shear force diagram and bending moment diagram. So here it is the shear force diagram both. So here this is the shear force diagram and this is the bending moment diagram for this example. Now let us understand how to draw this diagram. First of all we will take a section at the distance of x from this end. So our range will be 0 less than or equal to x less than or equal to L. In this range, what is the value of shear force? To finding out shear force, we will take algebraic sum of all the transverse force either side of this section. Here there is only one transverse load in the left side of this section, that is P. So our shear force F will be equal to P. Here this P load is in downward direction at the left hand side of this section, so it will be negative. Fine. So in the range of 0 to L, value of shear force will be negative P. So if we want to draw the shear force diagram for this case, then first we will take this direction as a x direction and in y direction we will take shear force. Here value of shear force is negative P. So our shear force diagram will be in this direction. It is constant throughout the length, so it will be a line parallel to the x direction and here this distance will be negative P. Now in this case we want to find out bending moment M. Let's say at this cross section we want to find out bending moment. So what will be the value of bending moment? It will be the load into distance. Here what is the value of load? Value of load is P and distance is x. So it will be P into x. Here this load is in downward direction and this moment will try to bend this beam like this. So we will take this bending moment as negative. So our value of bending moment is minus P into x. It is the bending moment at this section. Now for your information, we are going to find this bending moment by using formula, that is M is equal to integration of shear force, that is F into dx. Now what is F? F is equal to minus P. So it will be integration of minus P into dx. Here this minus P is constant, so it will be equal to minus P integration 1 into dx. Now what will be the integration of 1? It will be bending moment M will be equal to minus Px plus there will be constant C, right? Now remember that at the end of the beam which is free or either simply supported, if there is no any moment applied at the end, then the value of bending moment at that end is 0. So here this end is free and here there is no any bending moment applied like this. So value of bending moment M is equal to 0 at x is equal to 0. So if we put value of x 0, then this term will be 0 and M is 0. So finally C will be 0. So what will be the value of m? M will be equal to minus px. So here I just show you how to find out bending moment by using this formula. Just remember this method because we are going to use this method again and again. First we will use this equation and we will put value of shear force. Then by putting value of boundary condition we will get the value of bending moment. Okay? Now here this bending moment is in the range of 0 to L. And here you can see if we put value of 0 instead of x, then bending moment will be 0. So at x is equal to 0, bending moment is 0. So we will get this point, right? Here this direction is x direction and in this direction there is bending moment. Now here if we put value of L instead of x, then bending moment m will be minus p into L. So at the distance of L, the value of bending moment is minus p into L. So we will get this point. And you can see that this equation is the equation of line. So we will join these 2 points. So we will get this bending moment diagram like this. Clear? It seems difficult right now, but once you practice some example, it will be easy for you to draw shear force and bending moment diagram for the given example. Today we will stop here and continue in the next video. In next video we will see various type of example of shear force diagram and bending moment diagram. Till then try to understand this method from the notes. So we will meet in the next video. Thank you for watching.